Cool. So, welcome everyone. Everyone that's kind of looking us live now, or anyone that's going to pick that up later as a video on demand. I'm assuming this is going to be distributed in the usual way. It's really lovely to be here again, and I really enjoyed all the talks so far. I think they were really good, and some of them are really kind of uncovering some really good topics as well. So in my talk today, I will be talking about how to secure your Terraform sensitive values. And I believe we heard some of those kind of things talked about before in some previous talks. And with this talk, I really want to kind of deeper into the like basics and kind of try to share the knowledge of the basic stuff that I think a lot of people should be aware before they start doing any serious terraforming, right? So I think the basic question here is probably right. How do you know that you are secure enough, or what kind of security you really want there when you're deploying infrastructure as a code? And nowadays, everybody's using all these nice kind of fully managed SaaS SaaS solutions that kind of deliver all these kind of nice things out of the box. So, for example, you could go with and use Terraform Cloud, which really nicely manage all the platform for you. But really what you should be asking yourself here is, where does my responsibility starts, and where the responsibility ends? And HashiCorp Terraform Cloud is just picking it up from there, right? So there is another example here on that picture here, which is showing the GitHub pipeline for kind of automatically scanning for sensitive values in the code that you committed there. It does work, I believe, for public repos and the enterprise version for private repos as well. But the important thing here is, I think, to be aware that even though you're using a platform such as GitHub, Terraform Cloud that you're all familiar with, what things do we need as not end users, but like engineers and maybe architects of solution need to be aware of, right? Where what to watch out for, because all of those solutions won't deliver everything out of the box. Something is still left down to us. So probably the best kind of comparison is, you probably still remember that people tend to leave their keys under the doormats. Not sure if this is an international thing, but at least in most places in Europe I've been to, this seemed to be like almost like a national sport that, if we're not at home, just drop by, the keys under the doormat, right? So you might actually ask yourself, if you're doing that, you're literally compromising all these great security that you have. You can have all these alarm systems set up, I don't know what not, like, burglar-proof doors and super safe windows. But, if you're leaving the key under the doormat, that really kind of compromises the whole security posture, right? So I think here what we should really be saying is security through obscurity should never be the only security mechanism. And we should really be looking this as a wholesome thing that we need to be aware of, literally. And as it usually goes is, security is as strong as its weakest link. So let's make sure that there are not many weak links in our security chain there. All right, just quickly about me. I'm a senior consultant at the Scale Factory. We are a DevOps consultancy based in London. Luckily, before pandemic, we were already a remote first company. So even though we're based in London, doesn't help us much in this sense, but at least we kind of were prepared for it. We're also AWS advanced consulting partner and Kubernetes service provider. So all my demos later on will be based on the AWS services, but I will try to kind of always stress out that all the suggestions I'm making here and all the things that we're going to look at are kind of provider independent. So you should be able to apply those things across different providers. My previous roles mostly involved some roles such as senior IT infrastructure engineering and system architecting with an extensive Linux and virtualization experience. As Nick said before, this is not the only kind of space that we work in, but I quite like this kind of a niche industry or a niche part of the industry, and seems to be working quite nicely. I'm a firm believer and an active contributor in open source, and definitely a fan of automating and simplifying things. And with, when we still could travel, fan of hiking and cycling and also traveling. All right, enough about me. Let's have a quick look about topics that we're going to cover today, or at least I'm going to try to uncover some of the bits. First of all, I'm going to try to kind of really get down to the foundational stuff. And we're going to talk a little bit about how Terraform workflows work, what is the basic structure of the Terraform workflow that you run. And we're going to try to look at some of the security aspects and possible attack vectors and risks that lie there. We will see that it is really dependent on what kind of workflow you're using, and there are different kind of paths you can go down. After that, we will have a look at how people are usually handling sensitive values, or how those are actually handled in Terraform, what things to be aware of, and what kind of industry best practices there are to prevent any kind of sensitive values leaks. Next, I'm going to switch to my console, and we're going to do some demoing on all those examples that we're going to talk to. We're going to have a look at 3 basic kind of handling of sensitive values in Terraform. And we're going to try to demonstrate that to demo, and trying to kind of uncover some of the potential underlying issues that you might face doing that. And then I'm going to wrap it up with some conclusions and takeaways. And if there is time left, I'm happy to answer some questions from the chat, in the live chat in the YouTube channel. All right. So if we start with a really kind of a basic thing, so how would the typical Terraform workflow look like? So if we kind of abstract everything away from it, literally it's just having a user somewhere there that commits their configuration changes in some kind of a repo. It doesn't really necessarily have to be a repo, right? It can be just a local change for the sake of the argument, but usually how we do it, we usually put it in a repo somewhere where you will have your colleagues review it, and after a successful review, you would fetch it somewhere out of the repo, not necessarily on the same environment that you committed in, and then just do the usual kind of the plan apply phases on Terraform. And that would go and fetch different kind of providers and provision some infrastructure there on the right? And what we really want to kind of dive into more into detail here in this talk is how that central bit actually works. So when you have configuration stored somewhere in a repo, what are the kind of caveats or the things that, maybe not out of the box people are aware of or kind of think of first off? I mean, some of them will be quite trivial, quite obvious. Some of them maybe not. I hope at least it will be revealing for most of the folks listening us in. So if we have a look more into detail, like how the workflows work and what kind of workflows we can have with Terraform, we can probably literally split it up in roughly 3 kind of workflows, right? So the first one is the CLI workflow, where you can just use the OSS binary and maybe wrap it around with some kind of either custom wrappers or some wrappers that are being widely used by the industry as well, such as Terragrant, right? And the workflow is pretty straightforward. You have the code checked in, you checked it out, run your Terraform with the wrapper, and off you go. It provisions the infrastructure. But because we all want to follow the DevOps principles, obviously, all of that stuff is usually automated nowadays. So you can kind of nicely automate that workflow by just putting everything, in a nicely Git flow run or triggered pipelines. And for that, you can obviously use Atlantis, GitHub Actions, Circle CI, as we've seen before, or any other kind of providers in that space, right? And as a third one, I definitely want to kind of flag out here as well, because we are, after all, hosted by HashiCorp. It's the fully managed SaaS offering from HashiCorp, which is a Terraform cloud, which I really have to say, I really think they're doing an amazing job there by kind of combining everything together. So you end up with a fully managed solution, which provides you a fully managed workflow from the code commit all the way down to, provisioning the infrastructure, and then ensuring that you have all the audit trail and logs safely stored and available to you as well as needed. and at the same time, it provides a necessary level of collaboration between team members. So if you look at all those three workflow types, right? I mean, based on which one you go with, this kind of results in shift, or let's say different kind of exposure points that we might have to look into. So for example, the code and repository might live in a different place. The state and log files might be handled by, a managed SaaS offering, or maybe you're handling that yourself, or you're just offloading it to automated pipelines such as, I don't know, GitHub Actions, for example, right? Then, of course, the execution environment could be different. So if you're running it locally, it's just a local execution environment. If you're running in a pipeline, that definitely either spins up maybe on demand, like containerized environment, or you can have a pre-baked environment that you use every time and ensure that everything is in place as you need it. And then last but not least, the security perimeter and, like I already mentioned, responsibility, what we need to take care of might vary depending on what kind of workflow you're running. So let's have a quick look at 3 examples, or I would say 3 kind of basic examples where I would definitely like to kind of flag things out and make people aware that those things definitely are must-do checks when you're doing your Terraform runs. So the first one we're going to look at is secrets in code. So this is probably the most obvious kind of a pitfall that I would say probably makes most sense to people and are probably most easiest one to kind of pick out. So definitely, having hard-coded secrets or sensitive values in code is definitely not something that we would consider like a good practice. You should definitely avoid doing that. There are some out-of-the-box solutions that are trying to prevent that, such as repository scanning, like I mentioned before, maybe in GitHub. There are also kind of a lot of third-party tooling available around that as well, where you can just trigger on each commit and just scan your code for kind of predefined static hard-coded secrets that they might be left in the code intentionally or unintentionally. So if we look at the secrets in the code, what kind of remediation we can have there, right? So you can ask yourself. So first of all, I think the first kind of improvement there to work on is definitely try to dynamically inject values from the environment. That's definitely a really good first start there. So instead of hard coding everything in your Terraform code, better practice is definitely kind of getting it from the environment manually. Automatically. There are different ways how to achieve that. You can either specify a -var when running your Terraform, or Terraform by default picks up everything from the environment that starts with tf_var, and that would just automatically be parsed as a Terraform variable. And the second bit that probably gives you a little bit more security is, and what I think it's a kind of an industry go-to solution nowadays, is store your secrets externally in a sealed environment, such as a HashiCorp Vault, or maybe AWS Secrets Manager, or any kind of different other secret manager solution within your favorite cloud provider that you're using, right? So I believe every one of them has one. And definitely not just that, ensure that the sealed environment is encrypting at rest and in transit. And this is also important to kind of keep in mind. And maybe additional step that I would like to mention here as a kind of upgrade from just storing it externally in a safe sealed environment is try to randomize your sensitive values. We will have a kind of in detail look in the demo later on, but if you can just imagine provisioning a database somewhere, definitely better than having a predefined secret somewhere in a sealed environment. Maybe try to randomize the value, store it in the sealed environment, and just kind of fetch that value dynamically from a Terraform code. Obviously, there are different options how to attack this. A lot of sealed environments or external secrets manager do support automatic secrets rotation and such. So you might even want to do that rather than just pure randomization, right? But at this point, you probably would ask yourself, is this enough, right? I mean, is just having secrets moved out of the code enough to ensure that you run a secure infrastructure as a code? And as you would probably assume, it's not really. So the second bit that it's maybe more interesting and kind of hidden away from most of the simple Terraform runs is even if you're using external secrets, Terraform still needs to kind of, keep track and order of things that you are provisioning in order to detect the changes in the environment. So I would say that's probably one of the most important security aspects. Whenever I work with a customer, I think the first bit that I would like to check is if the state and the locking is kept safe when they're running their Terraform pipelines. Because like I said before, even if you're using external provider, whenever you feed in that value into Terraform, that eventually ends up in a state, which is a plain JSON file and unencrypted. So securing that bit of your workflow is definitely one of the most important bits that you need to kind of keep in mind. Bear in mind as well that when you're storing this, please ensure that you're using encryption at rest, and of course encryption in transit, which if in case of you're using like a fully managed SaaS solution like Terraform Cloud, that is already been ensured by the endpoint on the other side. The thing that I would like to mention here as well is there was an experimental feature in Terraform a while back where you could provide a GPG key and it would automatically try to encrypt those values. It didn't prove to be very efficient, and it has some drawbacks, and it wasn't very let's say user-friendly in a way that it would get adopted widely. So it is deprecated right now. And if you're using that, I would definitely recommend trying to stray away from that and maybe try to think about other things that are out there. Right. So we're already at the third bit, that the third kind of thing that I would like to kind of point out as well, which probably isn't the most important, but also a lot of times people tend to forget about securing their maybe outputs and audit trails as well. So for example, when you're doing logging or audit trail of your Terraform runs, usually you would like to be able to kind of go back and maybe if you're in the highly regulated industry, prove your changes for an auditor, or you're just keeping an audit trail because it's a good practice for all the changes going in. The good news here is that coming from Terraform 014 plus, there is a concept of so-called sensitive values. So it didn't just appear in 014, it was already present in previous versions. But in 014, it has become a non-experimental feature. So you can mark all your sensitive values, which are usually passwords or like some kind of tokens, as sensitive. The thing to be aware is it doesn't only work on a variable level. So for example, there is also a mechanism for providers to mark some of the values sensitive. So even though you think you're using a resource and you're not specifically marking things as sensitive, they might be redacted later on in the output because the provider implementation has actually marked that as a sensitive value. And of course, like I said, the responsibility might differ regarding which workflow you're using, but definitely worth keeping in mind that keeping your logs clean and CloudTrail clean from any kind of sensitive information or secrets is definitely a good practice here. And as usual, don't forget about the lock encryption and control access to those as well, as we mentioned in the previous couple of things. So before we dive into the demo, I would just like to start with a simple code example. So this is an example of a code, and literally how you would exclude having your secrets stored or hard coded in the code is literally just defining a variable. In 014 upwards, you can mark it as a sensitive value. So that would mean it would never be outputted in your Terraform plans or applies. And as well, it comes with the additional kind of limitation that I will mention in the demo later on as well. But it prevents you to kind of specifying and hard coding the password directly in the code. And as you can imagine, this can be literally injected in your Terraform runs as you need to do it. Okay, so we reached the time for demo. Let me quickly switch to my console. So this is a really simple repo with some Terraform code in it, as you're gonna see. I don't think it's that important what we're gonna deploy, but rather on, I would like us to focus there on the things that we kind of covered during the presentation before. So if we have a quick look at our main.tf, you're gonna notice, like I used in the example before, we are going to deploy an AWS DB instance. And it's just going to be a MariaDB instance. The reason I did that is it was probably, I just wanted to have something quick up and running without too much fiddling around all the additional options. So it's just the latest version, a micro instance. We're setting a name. And we're just going to hard code the username for now. And first, what we're going to do is we're going to provision a database, or better say, I already provisioned that because I wanted to avoid the wait time here. So we already provisioned that using an injectant variable here, which I will show you in a moment where it comes from. So if you have a look at variables.tf, you're going to notice that I have created a variable here, which is just a db-pass. It's a default DB password. The default's to null. I would explain why I'm doing this later on. And we're marking it as a sensitive value. And you might ask yourself, how are we going to inject this? So as I mentioned before, you can specify -var and then just specify variables equals values, or from the environment, which I'm going to do now using the terraform.tf vars file. So it has a really simple syntax. You just specify a variable equals the value of the variable, and we're just going to set it to farboo booyah value for now. So if we do a plan now on this, what you're going to notice here is I already provisioned that. So that's already been provisioned. And the thing that we want to do now is, first of all, as I mentioned before, let's try to do something more interesting here. So instead of having this variable marked as sensitive and pass it down as an input variable, what I would like us to do here is we will remove that piece of code, and what this actually does is it will generate a random pet name. It's just using a random provider, generating a random name. And this actually explains what why I was setting it to null. Is if it's going to be set to null, instead of using that variable, we're just going to use that randomly generated pet name and use it as a password for the database we're going to provision. To kind of close the loop here, we're also going to create a secrets manager secret and create a version that's going to have the database credentials stored in it. So we're going to store all the local variables in there. And when we're going to provision a database, what we're going to do is, instead of having that specify as a password, what we're going to do is we're going to simply pass this from the secrets manager directly and avoid having it stored somewhere, either on people's laptops or on some, God forbid, some small post-it somewhere, right? Okay, I'm just gonna save that now because I want to save some time. What I'm gonna do is I'm gonna quickly do Terraform apply, and I'm just gonna use auto approve here to avoid wait time. So as you see, it was very quick. The reason why it was quick is because I still have, sorry for that. I still have the value here, which I need to comment out. And the reason I didn't want to do it in one go is I just wanted to show you the state file, just quickly inspect that. And if we check the password, as I mentioned before, the state file does have that value in plain text in here. But as I mentioned before, it is marked as a sensitive value, so it won't be output anywhere, but the states still need to be secure. So let's go ahead and quickly apply that now. So this shouldn't take too long. What it's going to do is it's just going to replace the default credentials. So as you can see here, it's literally just generating a random name, which is, in this case, it's going to be called nearby Coro. It's a really nice, neatly generated pet name. And then what we're doing is, as you can see here, is just creating a secrets manager, generating the credential pairs, and just chucking that in. And now what is it doing automatically? It figured out that we're using a different value. So it just went and added that value into the, changed that value in the default administrator database access. And if we check here, the password actually changed, right? So I'm aware we are 5 minutes off. So I'm just gonna quickly show a couple of other things before we wrap it up. So the other thing that I wanted to show you is if we for some reason want to output that, we want to output those values. So what we're going to do here is just output the DB pass and pat, right? Because for some reason, we definitely want that to be outputted. And we're getting an error here, right? So as we can see here is I have a typo somewhere. And the reason is because I've removed too many comments. So try to. So, and it's still erroring out. So if we look at the error here, this is actually what I was going for. So sorry for that. And the reason is because we marked this variable as a sensitive value, it's actually saying it's refusing to output it as a plain value because we still need to mark it as a sensitive value here as well. So when you do an apply, it will actually know this is a sensitive value and it will prevent or it will skip it when outputting it on your terminal here. So as you can see here, we can actually emit the pet name, but it's not emitting the DB pass because it's marked as a sensitive value. So I think there is one step left in this demo, which is literally, like I said before, you probably don't want to end up with your Terraform store somewhere unsafe, like in my example, locally. I do use disk encryption here, so that's fine. But at the same time, I do want to collaborate with my colleagues. So what I can do here is, and what we will do in this case is, we will just simply just use Terraform Cloud for this. Like I said, I think it's a really neat solution that you can use, where you can just simply set your backend in Terraform configuration to remote, specify the organization name, which workspace this is going to be using. And just as you change that, be aware that when you're changing a backend, you need to reinitialize your Terraform local workspace again. And what that actually does is it's going to detect there is a change in our backend, and it's just going to offer us an option saying, okay, we're moving backend from local to remote. Do you want to copy that over? And in this case, we're just going to say yes. And if we do another apply real quickly, you're going to notice that there are no changes because we are still using the same state, but in this case, it's just stored remotely. And just to kind of show you that that's actually the case, we're just going to quickly have a look at my workspace here. It is using the local execution, so we won't see any runs here. But the thing that I wanted to show you is that the state actually ended up in my SaaS solution. It has a managed DB instance that was provisioned. It was modified a few seconds ago. And as I mentioned before, the password would still be in plain text. So where is it? Here it is. So password is still plain text, but we are storing it in a safe location, such as Terraform Cloud, where you have encryption in rest and encryption in transit. That concludes my demo here. So let's just quickly wrap it up. As soon as this one decides it's good to go. So to wrap it up, first of all, security is hard. I think we can all agree on that. But regardless of that, kind of my advice here, do protect your crown jewels. So watch out for where your code lives. So watch out the repository. Check regularly for your accidentally kind of hard-coded secret values there. Definitely watch out for your state. And as a last thing, be aware that logs needs to be safely stored and encrypted as well. So there are multiple layers of security, and you can still scan your code. There are multiple solutions that we already kind of heard about during the Hashi talks as well. So like DFSec, Checo, you can use cloud provider solutions as well. But I think what we heard on one of the talks as well is security usually needs to start with people. It's just not, it's never just a technology issue, is it? So the important bit is make your colleagues and community aware of their responsibilities and security risks, and let's all try to build a more safe and secure environment and not be the weak links in the security chain. Thank you for that. Thank you for being here with me today. I will leave with some further resources on the presentation. This will be shared later on at the HashiCorp forum, where you can find all the talk slides as well. And please do keep in contact. Reach out at any kind of social media or different kind of platforms that I'm on. Thank you.